Hello, everyone, and welcome on this second day of the first This is TIL Conf. And for this first talk, it's our keynote, and we are lucky to have Martina with us. Welcome, Martina.
Yeah, thank you so much. I'm so honored and excited to be here.
Yeah, we are too. And for this first talk, we are used to get libraries and frameworks to make shiny application, but we need to care about the security, and that's the goal of this first talk. So the stage is yours, and thanks again, Martina, to be here with us.
Yeah, thank you so much. As already mentioned, I'm really excited to be here and I'm actually quite nervous as well. So yeah, welcome everyone for the second day for the This is Learning conference this year. I'm so excited to kicking off the second day with a great topic in my perspective regarding what's the current state of security in single page applications. I'm doing a lot of security workshops and I always got asked the question, for instance, is cross-site scripting still a thing? Since we have a lot of built-in sanitizer rules inside the huge frameworks like Angular, Vue, React, Svelte. So is XSS actually still a thing? But there are still other things we need to consider when it comes to security in single page applications. So of course, you might asking yourself, so what are those things I'm talking about when I talk about security in single page applications? And of course, already mentioned, one of the things is cross-site scripting. So I want to answer the question, is this still a thing? Is these things still happening? Can we actually inject JavaScript code in a running React or Vue or Angular application? Secondly, I would like to talk about cross-site request forgery. What is there the current state? Can this still happen? And especially with the kind of rule set and cookie attributes and whatnot we actually can set, is this also still a thing? And of course, last but not least, and another big, huge topic of mine I'm really passionate about is the whole identity management thing. We just have 30 minutes, but I really want to give you a huge overview about these three main topics when it comes to security in a single page application. But first, let me introduce me myself a little bit further. Hey, I'm Martina. I'm from Germany, from the south of Germany, actually. I'm working currently as a consultant trainer and speaker for security and Angular, of course. I mean, I started from being a web developer like already 15 years ago. I did a lot of jQuery stuff and backbone, knockout, you name it. I guess you know all these kind of things. But now we reached a point, of course, where we have stable security, a stable front-end framework, basically with a lot of built-in security mechanism. And currently, I'm working as a security engineer for a company in Norway, actually, and helping them to making their apps actually even more secure. I'm also an OWASP team member. I guess you heard already of OWASP, the Open World Application Security Project. The OWASP Top 10 is always like the first point where to look at when we want to know a little bit more into security. And since I'm really into all the communities of Angular, I got honored to be a Google Developer Expert for Angular, to have a direct contact to the team and getting the news and being an active contributor to basically the Angular framework. So apart from that, let's start with the first topic, cross-site scripting. I guess all of you know the basic, what it is and what it could lead to. Just give you a short repetition what cross-site scripting actually is. Basically, cross-site scripting always occur when data enters a web application through an untrusted source, which is mostly like through a web request. For instance, we send our SPA sends out a request to a backend, and the backend has some malicious JavaScript code stored in the database, and then we fetch it, and then it got displayed and rendered in our web application, and then bam, the injection basically happens. Or it's the other way around, where data actually is typed into some input fields, and then of course got sent out to the backend and maybe stored. And these are like the two main points where we can inject malicious JavaScript code in our web application. We, as a security perspective, we divide XSS into three categories. We have reflected and stored, which is when I actually send bad malicious JavaScript code to a database, and the server basically stores it in a database. Also known as server XSS, because we need a server to actually execute this kind of bad XSS code. And we have, secondly, basically something that's called DOM-based XSS. So this is more related also to client XSS, since we don't need something like a server to have this JavaScript basically executed, since it's just got rendered immediately inside the HTML content. So this is a short sum up about XSS. And of course, one thing we always asking ourselves, is XSS still a thing in SPAs? And the answer is, like always, it depends. I mean, yes, you know it already. We have sanitizers. We have a lot of sanitizers in our like main front-end frameworks. And sanitizing, basically what it does is it detects malicious bad JavaScript code in some HTML and just removes it. This is really, really awesome and helps us already to actually mitigate XSS attacks, since, like for instance, Angular doesn't never trust anything that the user types into, or when anything we like to have an attribute binding to the inner HTML attribute, Angular sanitize everything. And of course, so does Vue and React. So basically, yes, with the built-in sanitizers of the SPAs, we have a huge mitigation of XSS if we're using this kind of frameworks. If you're not using this kind of frameworks, I always recommend DOM Purifier. It's a great HTML sanitizer library, but I actually would always recommend maybe just using a front-end framework, because we have a built-in sanitization. So yes, we could say XSS and SPAs got a lot better. And when we see the reports and what kind of CVEs are reported, yes, it got really, like it happened from the first place in the OWASP top 10 to the third place, since we got better and better support in SPAs for XSS. But the point is, we can bypass this kind of sanitizations, right? For instance, in Angular, we could inject the DOM sanitizer and just call something like bypass trust HTML to basically disable the sanitizer of Angular, which we should not do, but sometimes we have no other options to do so. As well, in React and Vue, we have something like an attribute we can apply to the HTML tag, and it gets basically this, and the sanitizer gets disabled. So we can't always control basically if the sanitizer is enabled or not. And for that, I always would suggest to add a second layer defense of XSS, which is called content security policy. And if you have never ever heard of it, I really highly recommend you to search for it right after the conference is over. Write it down in your notes and dig more into content security policy, because what it actually does, first of all, it's a response header, as we can see here. As an example, whenever I fetch some index.html file, I got it delivered, and there is a response header for this, which holds a content security policy. And in this content security policy, we have basically a rule set of all like of a couple of resources and where we can load them from, basically. So basically we could even tell, okay, I just want to load JavaScript code from this domain and from no other domain at all. I don't want to execute inline JavaScript at all, or I just want to execute inline JavaScript that has this specific kind of hash. So we have a lot of possibilities, which are even not just restricted to JavaScript execution, but also we can control what kind of iframes are displayed in our web page. If our web page basically is allowed to be embedded in an iframe of another page, all these kind of things. If plugins are allowed to be loaded, if from which source are, like from which origin we are allowed to fetch images, all these kind of things we can actually control with CSP. And all the process basically can read and evaluate the CSP and handle like the rules that we applied. We can have two modes on that. we have an enforcement. So the browser blocks the execution if, for example, the image, the style or style sheets, or even like the JavaScript violates our CSP rule set, the browser will not execute it at all. As well, we have a second mode, report only. For instance, if we are not sure if we applied the correct rule set, and of course, it could be the case that we break something that should work if we apply some CSP rule set. So we could apply it as report only, which means basically that we offer a report URL, and then the browser just posts some report on it like, hey, there was a user violated your CSP, but I still executed it. And the way of working is really, really simple. As I mentioned, I just load an index.html file. I get it back with a CSP applied as a HTTP response header. I maybe load another JavaScript file remotely from my own origin, and this is fine since I have applied the CSP rule set script source self, which means every JavaScript file that is loaded from my own self, from my own origin, is allowed to be, well, executed. And if now I inject malicious JavaScript code that tries to load something bad and differently, then the browser will definitely not execute it. So CSP is, of course, sometimes complicated or could be complicated, but I highly recommend you to take a further look. And I'm really, really happy to just ping me on Twitter or per email or whatever. I would really love to give more insights on that. I already gave some trainings and talks on CSPs. I really would love to help you. So if you want to know more about CSPs, just ping me. Because now we would like to go further with the second point, cross-site request forgery. A cross-site request forgery is like an attack that could really lead to bad things. One may be the harmless thing, but still something we of course don't want is, for instance, we have a page and we open the page, and there is an image which is not loaded correctly. And most of the times we are not suspicious about that because the browser sometimes try to load an old legacy image path, and maybe the server doesn't exist anymore. So we don't really overthink it twice or three times about, hey, there might be something wrong. But maybe there is, because maybe someone just insert an image tag with a URL in the source attribute that leads to something completely different. And whenever I open this kind of web page with this broken image inserted, I actually send a GET request to this kind of URL, right? Because this is what the browser do when it sees an image tag with the source attribute. It sets up a GET request. And even though right now here we just would maybe manipulate some survey results, or maybe we manipulate some views, like to have more views on a website, for maybe some advertisement revenue and so on and so forth. Even though these things doesn't harm us, this is definitely not something we want. A second example, which is even more worse, could be if we are maybe placing or embedding some kind of form HTML inside. And I maybe trick someone. Maybe I just send an HTML file, like some web page to Santosh, and tell him, hey, I have two cute kitty cats. You can open this web page and see my little cute cats. And of course, Santosh is a good friend of mine. He will open the page. Of course, I will never ever do this to him. Just as a side note, never. Definitely not. But of course, like, he will just open it because he wants to see my cats. And maybe I have embedded a form HTML, which basically maybe misuses his authorization cookies, because maybe before he opened the page, he maybe transferred some money from his bank account to someone else, and he forgot to close the browser session. So his authorization cookie that he is still logged in his bank account is still there in the web browser. And I use that because he now is on my website with the cats, and I have this form. And as soon as the form loads, basically, as here displayed, the form submits, and the browser does again what the browser do. And get the cookie because I have a cookie for this kind of bank URL and bank account. So I set the cookie. And now the authorization cookie basically is sent together with this form submission. This is really, really bad. I mean, on the other side, I can really calm you down. No bank system is working like that. I mean, right now we have really luckily secure bank systems, and we also always recognize so you got logged out after 5 minutes. So the cookie will be most probably deleted after 5 minutes from each bank account and from each browser. So there is really less risk that this actually could happen. But if we enable XSS attacks, we can actually have even more complex C-serve attacks like cross-site forgery attacks for our backends. And this is still definitely a thing. And I would like to tell you a little bit more how we can prevent that, especially in single page applications. Maybe you heard already, like in traditional web apps, like back old good days with PHP and whatnot, we yes, we set cookies, but we had something like a synchronized token pattern. We had a template engine, so we actually inserted and rendered some tokens directly inside the HTML because the HTML got delivered by exactly the same backend, which delivers also the data which will serve as an API. We don't have that anymore. We have an SBA that is completely delivered maybe from a CDN or from any kind of different web server than the data is actually coming from. So there's actually another algorithm or another pattern. We still can have some kind of prevention from C-serve attacks. And I would like to dig into that a little bit more. It's basically called double submit cookies. What it does. So the client inserts the password, username, or maybe passkeys, because passkeys are the new thing, maybe. And then the server basically, of course, checks if everything is right, if the password and so on, and logs in basically the user. And then it generates a so-called CSRF token. A CSRF token, which is like, of course, cryptographically perfect, so no one can really like guess it basically by accident or with a brute force attack. And the server sets a cookie and inserts the value of the token. And then it sets the token, which holds, it sets the cookie, which holds the token inside on the client browser. And whenever now the client receives this cookie, it injects the token from the cookie and adds wherever there is a form. Like of course, we always deal with a lot of forms in our SBAs as well. So it basically injects the token from the cookie, pulls it out, and insert it as a hidden input field in all the forms. And the cool thing about this is now that every single time when I submit a form now, the server expects this token to be also sent together with this cookie basically. And then the server checks, hey, is the token of the cookie actually the same as the token of the hidden input field, which got also submitted by the form. And if it's the same, yes, the server can be sure this is definitely a correct request from the right client. When we remember the example from before, like I just embed a form somewhere, this form would never ever submit this kind of token. Maybe the cookie is sent because this is what the browser do. It sets a cookie, but the token is not definitely sent. And of course, we could guess the token with a brute force attack, but for that, we definitely need to be sure that the token has a high entropy, that the token is not so easily guessed by cryptographic correct algorithms. Having that said, there's actually a second really easy applicable pattern which can prevent us from C-serve attacks. And this is, well, a custom request header. This sounds easy, but it is really effective because basically what we do is just, well, to each request, we add a custom request header. It could be x site C-serve protection equals 1. And whenever I send a request, the server expects this header to be set. And then everything is fine. And remembering all the attacks from before, like the form or the image with getting some survey stuff, this would not be able to to be sent because it would not include the header, right? So the server would say, okay, no, that's forbidden because I expect this header to be there. And this really easy little thing makes it already impossible, basically, to use browser mechanisms like just an embedded form or like an image tag. This custom request header actually leads to the point that the hacker or the attacker needs to set also this custom header by JavaScript. And the Java and for using that with JavaScript, he or she needs to first find out a possibility to inject JavaScript code in your web page. So this is already like a line of defense. We can easily prevent at least some kind of attacks, some kinds of CSRF attacks. So custom request headers are actually really easy to implement. We do not need a UI change. Really, basically, we just need, for instance, in Angular. Yes, I'm an Angular developer, so I always bring up Angular as an example, but Angular is also a single page application, so it fits. So basically in Angular, we have some kind of interceptor, and we would just intercept the request and add this kind of header. So there's no really big, huge deal of actually doing that. But it's even better because Angular, for instance, Angular has already a built-in protection for CSRF. It does automatically set an header if we just, basically besides providing the HTTP client and maybe some interceptors and whatnot, we also apply with XSRF configuration, where we basically tell Angular, here's the cookie name of the backend that set a cookie, and inside this cookie there's a token. So Angular actually implements the double submit cookie also. And what Angular does is inject the token out of this cookie and adds it as a custom request header. So it's actually a mixture of both patterns, right? And this is really cool. It's already built in, so it's really easy to actually just enable it, to be honest. Of course, it needs a backend that handles cookies and basically creates this kind of token. But it's really easy to protect ourselves from CSRF if we just follow so little simple rules, basically. That brings me to the last point of today, identity management. And this is something that should be like a 5 days workshop, of course. There are so many different kind of solutions how we can implement identity management. We can write a custom implementation, like we can maybe use Java Spring Security, we can use .NET Core. There are a lot of middlewares and libraries, also like the identity server for C#, where we actually can have all this OAuth and OIDC implemented by our own. Apart from that, we also have some already finished standalone solutions like Keycloak or Glue. I guess a lot of persons of you know already Keycloak, which we can just go up and running by a Docker container. But what I also prefer, and yes, okay, I'm a former worker, I'm a former advocate of Auth0, so yes, I like Auth0 a lot, and Okta, of course. But we have identity as a service solutions like Auth0, Okta, Azure AD, AWS Identity, you name it. And my recommendation is never try to implement identity management on your own. It is so hard. It just brings so many issues and problems to handle this access token, refresh token, ID token, to try to implement those things on your own. Considering the fact we using an identity provider, the only thing we need actually to care about in the front end in an SBA application is where we store this kind of tokens. So for instance, leaving the ID token maybe out, just having an access token, which holds the privileges for the APIs, right? So where to store this access token? And of course, there are some SDKs. For instance, Azure AD or also Auth0 provides some kind of client SDKs for Vue, for plain JavaScript, Angular, whatnot. And it basically does the work for you and provides you already with a default way where to store the token. And we can also decide to store it in a memory, basically, or in a local or session storage. But let me tell you one thing. To store a token in a local or session storage is one of the dangerous and worst thing you can actually do. You can't, you one is one does not simply store the token in the front end application and is completely protected from XSS attacks. That just doesn't happen. So soon or later, what happens is that we might have the kind of situation that basically our access token might be stolen. And this could be achieved really easily. Of course, what we do then is maybe setting the lifetime of the access token just for 5 minutes or 3 minutes. That if it gets stolen, then yes, we have at least that it just have the lifespan of maybe 3 minutes more, 2 minutes more. But also 2 minutes already enough time to do some bad stuff. But then, of course, we would enforce the user to re-log in each 5 times, right? Every 5 times, not 5 times, sorry, every 5 minutes, we ask the user to log in again. Of course, for that, we have another solution, we have refresh token. And I mean, basically how it works is we get an access token and a refresh token one, and as soon as the access token one expires, we ask the identity provider again, hey, I want to have a new access token. Please give me a new access token and a new refresh token. And yes, the identity provider gives it back to us. And now we have an access token 2 and a refresh token 2. So what usually happens, and what happened already so many times, that someone is actually able to steal this refresh token 2. And yeah, what we could do now, or the hacker can do now with this refresh token 2, is basically getting another access token 3 and maybe another refresh token 3 as well. So yes, now the hacker has actually an access token 3. And if maybe, and this is the worst thing that could happen, maybe we closed already our application. So our application, which is the right owner, let's say it like that, of the refresh token 2, will not get another refresh token after 5 minutes because we closed the application. We do not need to do something anymore on our website, on the website as a user. And if this happens, the hacker can actually, after 5 minutes, it can actually get another access token and another one and another one and another one if the application is already closed. I mean, of course, if it's not, at one point, the application would also try to get another access token with the refresh token 2. And then the identity provider would say something like, oh, there is something completely messed up. Oh, I tried to revocate the refresh token. But yeah, as you already maybe know, the revocation of an access token isn't that easy and actually not really possible. That brings me to my last suggestion for today, to getting more and more not into storing the access token in a local or session storage, but on the server with a backend for front-end pattern. And I saw that today actually there is a talk about this. So I just wanted to give a short overview what this is about. And I highly recommend for you to actually visit this talk, because this is like the best way to actually having your token really secured. And this is already implemented by so many huge companies. And it's like the best practice pattern, at least in my sense and in my suggestion. I mean, the identity providers and the SDKs of them, they're doing a great job, but this is the most secure way in my perspective. So basically we have 4 players in this kind of pattern. Of course, you have the front end and the back end, and then we have the front end for back end, basically. We have our identity provider, which I just said that it's a 0 in that point. And we have external API, the external API, which we fetching together with the access token some data we need privilege to. So we log in basically to our backend, and the backend is now doing the whole OAuth OpenID Connect flow stuff together with the identity provider. And then we are getting from the identity provider the access token, ID token, refresh token, the things we need maybe for our user basically. And what the backend does, it stores, it holds the access token, all the tokens itself. It will not pass them to the front end. It just holds them. It creates a cookie, an encrypted cookie basically, and just the cookie is set to the front end. And whenever the front end now needs some data from this external API, the back end reads the cookie and sees, okay, for this cookie, I have this kind of access token, and passes the whole request to the external API. And then basically moves and forwards the whole API response if the access token is validated correctly and the user has, of course, the privileges back to the front end. And as already mentioned, this is basically the best practice how to store a token in a single page application. And again, I really highly recommend to watch this talk about backend for frontend. Additionally, if you want to learn more about this kind of token stuff, I can highly recommend you Dr. Philip de Rick. He's so amazing. Just Philip de Rick, I guess it's a name that maybe everyone who has something to do with identity knows this name already. Definitely check out. He has some free courses as well on his website, Pragmatic Web Security. It's amazing. I personally learned a lot from him as well. That brings me to the point that I can say just thank you so much for watching my keynote. Of course, I provide the slides afterwards, and I will hang out with you in the chat on YouTube, of course. If you have some question, I try to answer them. Thank you so much, everyone, for listening to my talk. I'm really happy for you, like for me being here, and I hope I got some insights for you and you learned a little bit. So thank you so much again.
Thank you, Martina. You have no excuses now to create insecure applications. So you have all this content. It's already available on YouTube if you want to watch it once again. I shared the agenda. So we have four tracks, which would start in a few seconds about cloud and backend, about AI, ML, CI, CD, and about web and mobile. So you're welcome to join them.
Thank you.